the first derivation, we have that Laplace transformation of exponential at will give you 1 over x minus 1 a from our proof. Now, if you have this as Laplace transformation, you have Laplace transformation of this equal to this. Now, let me take, if I take my a, assuming I take a, if my a is equal to 0, then I'm going to use this value, the value of a, and then substitute it from this derivation, from this equation. I will have something like this. Laplace transformation of exponential, my a now will be 0 times t, will give you 1 over x minus what? 0. Why? Because I'm taking my a now to be 0. So when you take the value of x to be 0, and then you substitute it here from the equation, you have that exponential raised to the power of 0 times t. 0 times t will give you what? 0. So you have a Laplace transformation of exponential raised to the power of 0, and then is equal to 1 over what? X. Now, what is, you have exponential raised to the power of 0, and anything raised to the power of 0 is what? 1. So finally, we're going to have Laplace transformation of 1 will give you 1 over what? X. This is how you obtain Laplace transformation of 1. Just know that if you are solving any question on Laplace transform, and then you have 1, and then you say find the Laplace transform of 1, just know that your Laplace transformation of 1 will give you 1 over what? X. This is how you get your Laplace transformation of 1, and it will give you 1 over what? X. So now, I also need to obtain another formula. Now let's see what if you are asked to find Laplace, find what? Laplace transform of t raised to the power of what? N. In this case, this time I are asked to find Laplace transform of what? T raised to the power of n. Now, you should also know that your f of t will give you your t raised to the power of n. Since you say you should find Laplace transformation of t, just know that this value, t raised to the power of n now, will be your f of t. So therefore, your f of t will give you t raised to the power of n. So all you need to do, you will now do what? You will now use the formula for Laplace transformation, and that formula will give you f of x will give you the integral sign from 0 to infinity, then you have exponential raised to the power of minus st multiplied by f of t times what? The t. So this is the formula for the conversion. Now this thing is like, when you say transform, you are transforming from a function to another function. So now, know that you should know that the question is formula. The Laplace transform of f of x, which is f of x will give you Laplace transform of from 0 to infinity. You have exponential minus st multiplied by f of t times what? The t. Now, what am I finding now? What am I looking for? I'm looking for the Laplace transform of t raised to the power of n. Now, what I'm going to do is that, and also, okay, since I said let my f of t equal to what? T raised to the power of n. So now I'm going to substitute this f of t into this equation. Now my equation is f of t, or f of x will give you the integral from 0 to infinity. Then I have my exponential minus st. Then this exponential minus st will multiply f of t. And what's my f of t? My f of t now is equal to what? t raised to the power of n. So I will now write t raised to the power of n. I will there times the t. So it's still the same as the integral from 0 to infinity. Then I have t raised to the power of n, and I have e raised to the power of minus st times what? The t. So you're going to have it in this form. So whenever you have integration, an integral form, mind you that this is integration sign. If you are integrating a function, multiplying another function, in order to solve it, in order to integrate it, you are going to apply what? Integration by parts. And now the formula for integration by parts will give you uv minus integral of what? Integral form of v du. So this is the formula. This formula is what we call integration. The integration by what? Parts. This is integration by parts. So this formula, we can derive this formula from product rule of differentiation. So when you have product rule from differentiation, you will now get this formula integration by parts. Now, I wouldn't want to show you how I got this formula, but this is integration by parts. How do you get it? We get it from product rule formula of differentiation. So now, this is integration by parts. So I can take my u now. I can say let u, my u equal to t raised to the power of n. You understand? T raised to the power of n. So now what do I do? I want to differentiate this with respect to t. If I differentiate u with respect to t, it will now be, this is t raised to the power of n. It will now be this n that is the power. You have power n, which is n, we multiply, you now have n, we multiply t, we multiply this t. Then you also need to write the power and then you subtract 1 from the power. This is how you differentiate u with respect to t. Knowing that this t is carrying a power of what? N. So it will not be this n times t. Then you subtract 1 from the power. Then finally, you're going to have something like this. If this one will come over here, you now have du will be equal to, u will give you this n, you have your n t raised to the power of n minus 1. Then this multiplied by this will give you the t. So therefore your u will give you n times t raised to the power of n minus 1 times this the t. Because this one now will multiply this. So you have du is equal to this. So now I will now take this exponential minus st times the t. So let me say the v. My v now will give you exponential minus st times what? Times what? T. Are we there? Times what? T. Which is times the t. So now, what I'm going to do now, I want to get a value for t now. I want to get a value for v. And how do I get a value for v? I will integrate, meaning that the integration of the v is also known as the integral. So the integral form of v will give you what? V. And my v will give you integral of this exponential raised to the power of minus st dt. So you should know that the integration of the v will give you v, and v will give you, since you are integrating this, it will also integrate this one too. You also need to integrate this exponential raised to the power of minus st times t. So that is why the integration sign now will affect both sides, both this and this. So knowing that your integral form of the v will give you what? V, and then you're going to have v is equal to this. So now, if you integrate exponential minus st dt, now it will now be like this is a minus sign. This is a minus sign. So you will now have minus 1 over x. Minus 1 over x. Then you also need to put down the same exponential here. So you have exponential minus st. You're no longer, you're not going to add the t again because you have already integrated. So there's no point you writing including the t again. So you remove the t because you've already integrated. So finally, your v will give you minus 1 over x, the integral multiplied by exponential raised to the power of what? Xt. So this is the value of your v now. So from this analysis, I'm going to repeat these things. I'm going to put them into the formula. Which formula? The formula is our integration by what? Parts. So this is integration by parts. So I'm going to put them here. So let me clean up these points. So I have these are the values here. So I'm going to put it here from the formula. I have, where is my u? My u is t raised to the power of n. I have t raised to the power of what? N. U, which is u is equal to t raised to the power of n. V, which is my v now, is from the integral of the v, which is this. I have my v, which is bracket minus 1 over x exponential minus st. So now, this and this is your uv. So the next one is minus. I have minus integral. There's a minus integral of v. Where's my v? Where's my v? My v is minus 1 over x here. They have integral form of minus st. Then multiply by what? Du. My du now. This is my du now. My du is equal to n times t raised to the power of n minus 1 times t. I have times n multiplied by t raised to the power of n minus 1 times what? The t. So this is what I'm going to get. So now from here, I'll still write my t. I still have my t raised to the power of n here. From this point, also multiply by minus 1 over x exponential minus st, which is this. Now, this is minus. I have minus integral form of minus 1 over x, then multiply by the exponential minus st times n times t raised to the power of n minus 1 times dt times dt. So now I have t raised to the power of n into minus 1 over x, and then I still have my integral form of minus st. Then I have this 1 over x and n are constant. 1 over x and n are constant. So if you multiply this n by minus 1, it will give you minus n over what? X. So you will now have minus into integral of this by this. N times minus 1 give you minus n over what? X. Then you now have the integral, you have your exponential raised to the power minus st times this n now is your n here. So you are left with what? T raised to the power of n minus 1 times what? The t. So we are going to have it this way. Now, the next thing we are going to do, now since our n over s is constant, so mind you, if you have a constant in integration sign, all you need to do, you remove the constant away from the integration sign. So I'm going to pull off n over x out from the integration sign because it's a constant. So I'm going to have t raised to the power of n into minus 1 over x into 1 minus x exponential minus st. Then this is minus, the constant is carrying a negative sign. So if you bring it out here, it will now be minus n over x. Then I'll still include my integration sign. I still have my integration sign, which is exponential minus st times t raised to the power of n minus 1 times what? The t. So mathematically, we all know that minus times minus will give you what? Plus. So automatically, this place now change to what? Plus. So we're going to have t raised to the power of n multiplied by minus 1 over x exponential minus st. Then this now becomes what? Plus n over x. Then you have the integral of exponential minus st times t raised to the power of minus 1 times what? The t. So now, I want to include my limits. Now, if I'm to include my limits, I will now include the limit from 0 to infinity as usual. And I have t raised to the power of n. I have into minus 1 over x exponential minus st. So this is the limits. Our limits are from 0 to infinity. I have from 0 to infinity. From 0 to infinity plus n over what? X. Then this is the integration sign. This is my integration sign that I have still 0 to what? Infinity. 0 to infinity. Then I multiply it by this integral of minus st times t raised to the power of n minus what? 1 times what? Dt. So if for this side now, I will now still do the same thing. For me to evaluate this one, I will now do the same thing. Say the upper limit minus lower limit. So which one is the upper limit? The upper limit is my infinity, then the lower limit is my 0. So if I take my upper limit minus lower limit, let me see what I'll get. So let's say this is t raised to the power of infinity. I'm working on the upper limit. I have, sorry, this is t. I know that our t are 0 and infinity. So now I'm beginning with the upper limit. So this t here is my infinity. Infinity raised to the power of n. Then multiplied by minus 1 over x. I have my exponential. Multiplied by exponential raised to the power of minus x times, this is t. And my t here is the infinity. Is my infinity. So I have this. So minus this one is my upper limit minus the lower limit. My lower limit now, I will still include everything here. So I will still start my t. My t raised to the power of n now will be 0 raised to the power of n because I'm on the lower limit. And my lower limit is 0. So I have 0 raised to the power of n. And then I have multiplied by minus 1 over x. Minus 1 over x. Then times this exponential. My exponential raised to the power of minus x times what? 0. Because my t is 0. So I told you that I said our limits are 0 and infinity. And these limits between 0 and infinity are values of what? T, our t's. So meaning that since here is my lower limit, the value of my t here now becomes what? 0. So now I have something like this. So now this is upper limit minus lower limit. I told you that if you have an exponential carrying an infinity symbol, this is infinity symbol. You have an exponential and there's an infinity here. That is exponential raised to the power of infinity. We give you 0. So that 0 now times minus 1 over x will give you 0. And that same 0 multiplied by this exponential raised to power of what? N. We still give you 0. So meaning that our upper limit now becomes what? 0. So now minus the lower limit. This is the lower limit. I have my lower limit. My lower limit is 0 raised to power of n. It still give you 0. It's like n now will be a value. So if you have 0 raised to power of anything, it will still give you 0. So now you have your 0 here, multiplied by minus 1 over x, exponential minus x times 0. Now, x times 0 will give you 0. 0 times minus will give you 0. So you now have exponential raised to the power of 0. And exponential raised to the power of 0 is what? 1. Because anything raised to the power of 0 is what? 1. That 1 times minus 1 over x will give you minus 1 over x. And this minus 1 over x, if you multiply by this 0, because this one is 0, you understand? If you multiply it, it will still give you 0. So both your upper and the lower limit is what? 0. Are you getting me? So this one now, the evaluation of this one now is this, and this, because I evaluated this using the upper limit minus lower limit, which is this. This one has the upper limit and this one has the lower limit. And then, mind you, there is a plus here. I say plus n, this n over what? X. Then times this integral. This is the integral from 0 to what? Infinity. Then I have exponential minus st times t raised to the power of n minus 1 times what? Dt. So now you don't have plus. You say plus n over s is written here. They have the integral form of 0 to infinity, then exponential minus st times t raised to the power of n minus 1 times what? Dt. So 0 minus 0 will give you 0 plus n over s multiplied by this. It will now give you n over s multiplied by the integral form of 0 to infinity multiplied by exponential raised to the power of minus st times t raised to the power of n minus 1 times what? Dt. So finally, it should not be like your Laplace transform. The Laplace transform of what? Laplace transform of t raised to the power of what? N will give you n over x. Then the integral of 0 to infinity exponential minus st times what? Times t raised to the power of n minus 1 times dt. So mind you, this as it is like this will give you this, because this is like we are looking for the Laplace transform of t raised to the power of n, it will give you this. So it's the same thing as n over x. This one now is the same thing as Laplace transformation. The same thing as Laplace transformation of t raised to the power of n minus 1. N minus 1. This is what I'm going to get. So it's the same thing as Laplace transformation of t raised to the power of n minus 1. This is what I'm going to get. So it will actually give you Laplace transformation of t raised to the power of n. So now it's the same thing. You can write it this way. Or this integral sign 0 to infinity. Then you have exponential e raised to the power of minus st and the t. This and this integration sign now represent this integral form. You represent this Laplace form. So that's why I'm adding the whole of this. I'm adding this and this and this. I'm representing this and this as the integral, as the Laplace symbol. This is the Laplace symbol. I represented this Laplace symbol of t raised to the power of n minus 1. So now, this will give you this. Now, if if you are to look for the Laplace, assuming now if you have t raised to the power of n and you have n over s, then the Laplace transform of t raised to the power of n minus one. So meaning that if you are looking for Laplace, assuming now you look for the Laplace transform of t raised to the power of n minus one, eh? It will now be like this one. This is the first one now. It will now be like n into n minus one over x times what? X. You understand? Then now you still have something like this. Your Laplace symbol. You still have your Laplace symbol as t raised to the power of, it will now be t raised to the power of n minus what? 2. It will no longer be n minus what? 1. Because we look for the Laplace transform of t raised to the power of n, and we got this t raised to the power of n minus 1. Now, if you look for the Laplace transform of t raised to the power of n minus 1, you will now have n into n minus 1 over x times x. Then you will have the Laplace transform here, just like the way we did this one. You got Laplace transform of t raised to the power of minus 1. So this one now will now be t raised to the power of n minus 1. So if you are looking for, what if you are looking for the Laplace transform of t raised to the power of n minus 2? It will now be n into n minus 1. Then since it's n minus 2, you still have, you now end at n minus 2 over x times what? X. So you still multiply by the Laplace transform. Since this one is n minus 2, here now will be t raised to the power of n minus 3. So it's like if I'm moving to Laplace transform of t raised to the power of n minus 2, n minus 3. So it will still give you n into n minus 1 into n minus 2 into n minus 3 all over x times x times x times what? X. So you still have something, this Laplace symbol. If this one is n minus 3, here will be t raised to the power of n minus 4. So the more you are going, if you are going, here now will be changing to, here will be, if you move to the next one, it will not be, if you move to the next phase, it will not be n minus 5. So it keeps changing. The values of your t, the power of your t now keeps changing as you move, as you keep going, it will change. So now finally, so it's like, what I'm doing this thing now is for you to understand where I'm heading to. So now, if you have a Laplace transformation, from the first one, I have Laplace transformation of t raised to the power of n, I have n over x, the Laplace transformation of t raised to the power of n minus 1. So if you do the same thing, if you look for the Laplace transform of t raised to the power of n minus 1, it will not give you, so that will be n into n minus 1 all over x times what? X. Then this one now, you write this symbol, which is the Laplace symbol. So this one now will no longer be t raised to the power of n minus 1. It will now be t raised to the power of n minus 2. That is if you are to look for the Laplace transform of t raised to the power of n minus 1. So it is equal to, now if you are looking for the Laplace transform of t raised to the power of n minus 2, it will now be n into n minus 1, then n minus 2. You stop at n minus 2 because you are looking for the Laplace transform of t raised to the power of n minus 2. Then you now have over x times what? X. Then it will now be this, it will now be Laplace transform of t raised to the power of n minus what? N minus what? 3. N minus 2. So now look at this now. So this one now will be, so okay, sorry. You have this one that is n. If you take the Laplace transform of this, t raised to the power of n minus 1, it will give you this. So if you take the Laplace transformation of t raised to the power of n minus 2, you have this one. You now have n into n minus 1 times n minus 2 over s times s times n. And this one now will change. So as you keep going, the value of the power of t will be changing. You understand? It will change. So finally now, you have something like this. Now, what if I take my n now? What if my n now becomes what? 4. If I take my n now, the power of n now becomes 4. If here is 4, here now will be 3. Why is it 3? 4 minus 1 will give you 3. So this one now will be the same 4 minus 2 will give you 2. So here now will be like same 4 minus 3 will give you what? Will give you 1, isn't it? So now, what if you move to the next one now? If I take a Laplace transform of t raised to the power of n minus 3, I think I will have something like this. Which is I have n, that is taking Laplace transform of t raised to the power of n minus 3. It will now be n into n minus 1 into n minus 2. So since it's n raised to the power of minus 1, I will stop at n raised to the power of what? Minus 3. Are you getting it? Over x times x times x times what? X. So this time around, since I'm taking Laplace transform of t raised to the power of n minus 3, it will not change now. This one will no longer be t raised to the power of n minus 3. Instead, it will be t raised to the power of n minus 4. I said it, if you keep going, the power of t will keep what? Changing. As you are going, it will keep changing. So now I now say, okay, if my n is, if I take my n now to be 4, here is 4. 4 minus 1. 4 minus 1 is what? 3. 4 minus 2 is what? 2. For here, 4 minus 3 will give you 1. Then for here, n, 4 minus 4 will give you 0. Are you getting it? 0. So t, it will now be t raised to the power of 0. It will now be t raised to the power of 0. And t raised to the power of 0. I said that anything raised to the power of 0 is what? 1. So you will now have, finally, you're going to have something like this. Let's say this is, as I'm moving this way, this is n into n minus 1, into n minus 2, into n minus 3. So I cannot assume this multiplied by this times this will give you n factorial. It will give you n factorial. Because I'm having n multiplied by this n minus 1, multiplied by n minus 2, multiplied by n minus 3. So it will give you n factorial. Factorial over. Now, this s is set that s raised to the power of 1. S raised to the power of 1. S raised to the power of 1. So I can say s raised to the power of what? N. This n can be 1, can be 2, can be 3. It's a value. So I have s raised to the power of what? N. So now I have Laplace transformation. This is the Laplace transformation of t. Assuming now I say here I take my n to be 4. So here that is 4, that is n minus 4, will now be 4 minus 4. And 4 minus 4 will give you 0. So if you have 4 minus 4, 0, meaning that you are going to have your t raised to the power of what? 0. It will not be t raised to the power of 0. And any t raised to the power of 0 is 1. So it will not be, finally, this n factorial all over x raised to the power of n times, then this one is 0. So it will not be Laplace transformation of what? 1. It will not be Laplace transformation of 1, knowing that t raised to the power of 0 is what? 1. And so Laplace transformation of 1 will give you 1 over s. Remember the second derivation. Like I said, if you take your a to be 0 from the first derivation, you will have your Laplace transformation of 1 equal to 1 over s. So finally, you're going to have n factorial all over x raised to the power of n times 1 over x, because Laplace transformation of 1 will give you 1 over x. And mind you, this one is x raised to the power of n multiplied by x. And x now is the same thing as x raised to the power of 1. So if you do your mathematics, you're going to have n factorial. You're going to have n factorial all over. Okay, let me move to this other side. Then you have your n factorial all over x raised to the power of n times 1 over what? X. So your x is the same thing as x raised to the power of 1. So finally, you are going to have your n factorial all over x n plus what? 1 from your indices. So if you multiply this indices, from indices you have your, if you have x raised to the power of n times x raised to the power of what? 1, because your x is the same thing as x raised to the power of 1. So this and this, they are the same. You pick one. So you now say x raised to the power of the first power is n. So since it's times, it will be plus 1. Because this one now, your x now here is power of what? 1. So if you apply this, you are going to get it this way. So finally, you have something Laplace transformation. That's a Laplace transformation of Laplace transformation of t raised to the power of n. Finally, is going to give n factorial all over x raised to the power of n plus 1. This is the final answer. This is the second formula. This is the second formula.